If you haven't used Code Composer Studio before, Lab 2 will let you acquire some basic skills with it. If you're an experienced Code Composer user, consider this a refresher. We're going to recreate the temperature sense demo and reprogram it into the flash memory of the MSP430. If you want to fully test all the features of the part, you should solder the microcrystal included to the kit to the board. A link is provided to the steps needed, along with a program to test whether you've done the job right. The objective of this lab is to learn the basic features of Code Composer Studio. So the first thing we need to do, if you're following along in the workbook in Lab 2, in Step 1, start Code Composer Studio by double-clicking the icon on the desktop or selecting it from the Windows Start menu. When Code Composer loads, a dialog box will prompt you for the location of the workspace folder. Browse to C:\MSP430 LaunchPad under Workspace and do not check the Use this as the default checkbox. Click OK. This folder that we set up will contain all the CCS custom settings, which includes project settings and views when CCS is closed, so that the same projects and settings will be available when CCS is restarted. The workspace is saved automatically when Code Composer is closed. In Step 2, the first time Code Composer opens, a Welcome to Code Composer Studio 4 page appears. Close the page by clicking on the CCS icon in the upper right or by clicking the X on the Welcome tab. You should now see an empty Code Composer Studio workspace. The term Workbench refers to the desktop development environment. Maximize Code Composer Studio to fill your screen. The Workbench will open in the C++ perspective view. Notice the C++ icon in the upper right-hand corner. A perspective defines the initial layout views of the Workbench windows, toolbars, and menus that are appropriate for a specific type of task, like code development or debugging. This minimizes clutter to the user interface. The C++ perspective is used to create or build C++ projects. A debug perspective view will automatically be enabled when the debug session is started. This perspective is used for debugging C++ projects. You can customize the perspectives and save as many as you like. A project contains all the files you'll need to develop an executable output file, an out file, which can be run on the MSP430 hardware. To create a new project, click File, New, CCS Project. In the project name field, type Temperature under Sense under Demo. Uncheck the Use Default Location box. Click the Browse button and navigate to C:\MSP430 LaunchPad /labs/lab2/project under TS or -TS. Click OK and then click Next. In Step 4, the next window that appears selects the platform and configurations. The project type should be set to MSP430. In the Configurations box below, leave the Debug and Release boxes checked. This will create separate folders that will hold output files for each type. Click Next. In Step 5, in the next window, inter-project dependencies, if you had any, are defined. We don't have any, so select Next. Step 6, in the last window, the CCS project settings are selected. Select the device variant using the pull-down list and choose MSP430 G2231. This will select the appropriate linker command file, runtime support library, set the basic build options for the linker and compiler, and set up the target configuration. When you've found that part, and it's a long list, click Finish. In Step 7, a new project has now been created. Notice the C++ projects window contains the temperature sense demo. The project is set active and the output files will be located in the debug folder. At this point, the project does not include any source files. The next step is to add the source files to the project. To add a source file to the project, right-click on Temperature Sense Demo in the Projects window and select New Source File. Or from the top of the top menu, you could have clicked File, New Source File. Name the source file main.c and click Finish. An empty editor window will open for the main.c code. We're now on step 9. Next, we need to add the code to main. Rather than create a new program, we're going to use the original source code that was pre-programmed into the MSP430 G2231 device, the program that we ran in Lab 1. So click on File, Open File, and navigate to C:\MSP430 LaunchPad, Labs, Lab 2, Files. Open the temperature sense demo.txt file. Copy and paste its contents into main.c. Control A, Control C. Now you can paste it into the main file. Control V. You can go ahead and close the temperature sense demo.txt editor window. That file is no longer needed. Be sure to save main.c by clicking the Save button in the upper left of your screen. 3 buttons on the horizontal toolbar control code generation. Hover your mouse over each button as you read the following descriptions. Note the Build button, the Rebuild button, and the Debug button. Step 11, click the Build button and watch the tools run in the console window. Check for any errors in the Problems window at the bottom of the screen. If you get an error, you will see the error message in red in the Problems window. By double-clicking the error message, the editor will automatically open the source file containing the error and position the mouse cursor at the correct code line. For future reference, realize that a single code error can sometimes generate multiple error messages at build time. In step 12, CCS can automatically save modified source files, build the program, open the debug perspective window, connect and download to the target, your flash device, and then run the program to the beginning of the main function. Click on the Debug button, the green bug, or you could have clicked Target Debug Active Project. Notice the debug icon in the upper right-hand corner, indicating that we are now in the debug perspective view. The program ran through the C environment initialization routine in the runtime support library and stopped at the main function in main.c. In step 13, the basic buttons that control the debug environment are located at the top of Code Composer Studio. The main ones you're going to want to notice are the Run button that looks like a play on a Meteor controller and the Stop button. There are others there, and those are listed in the table that you see in the lab steps. Step 14, at this point, you should still be at the beginning of main. Click the Run button to run the code. Notice that the red and green LEDs are toggling as expected, so we know that the application is running on the board. Go ahead and click Halt. The code should stop in the pre-application mode function. In step 16, single step the step into the code once and it will enter the timer ISR for toggling the LEDs. Single step a few times, and if you're watching the board, you'll notice that the red and green LEDs alternate on and off. In step 17, click the Reset button and you should be back to the beginning of main. In step 18, the Terminate All button will terminate the active debug session, close the debugger, and return us to the editing view. Click Target Terminate All, or you can just use the Terminate All button that looks like a stop. That will close the debug session and so on to bring us back. By the way, there's cheat sheets that come up every once in a while on the right side of the screen. If you find them interesting, read them. If you don't, you can close them by clicking the X on the side of it over there. In step 19, close the project by right-clicking on Temperature Sense Demo in the Projects window and select Close Project.